Hey, working with angle addition. Um, Once again, you should have written down on that sheet of paper so you have access to it. The ideas of what the angle additions are. We're going to be dealing mainly with just applications of that, with dealing with numbers. Let's take a look. I'll take a look at number 6. Once again, as we talked about yesterday, you should have up in the upper right-hand corner your two angles that you're dealing with. Angle A is in quadrant number 2, and the cosine is -4/5. This is a 3, 4, 5 triangle, and I'll keep them for these types of problems. I'll keep them as just normal fractions. I won't throw radicals in here. It's hard enough as it is having to deal with radicals. Angle B is in quadrant number 1. The sine of that is 5/13. You should remember your Pythagorean triples. 3, 4, 5 triangles, I utilize quite a bit, and 5, 12, 13. I'll utilize these two triangles quite a bit. So if you know your Pythagorean triples, that will be beneficial to you. And problem number 6, I'm asking you to calculate the cosine or cotangent of A minus B. The cotangent of A minus B, which by our reciprocal ideas, this is equal to 1 over the tangent of A minus B. So when you calculate this, when we deal with our calculations, you're going to come down to a fraction. You're going to come down to a fraction. When you just get done with your solution, just flip it over. This just tells us to reciprocate whatever we get for the tangent of A minus B. So what we need to calculate is the tangent of A minus B. First thing I suggest you do is just write out. Don't try to substitute numbers in yet. Expand out tangent A minus B. Just look at your formula. What's the tangent of A minus B? Expand it out. Don't try to substitute numbers in yet. Okay, it's confusing enough as it is right now. Just expand tangent A minus B out. And you should be able to pull off your worksheet or off your list of formulas there. You should just be able to pull that off. Once again, don't try to sit there and have to worry about going through my notes. Now, do not try to do too many things at once here. Just write it out with your tangent A, tangent B. Now we can do our substitutions. Looking at our triangle, what is the tangent of A? What is the fraction that's the tangent of A? What is the tangent of B for my triangle up there? And on the bottom, what is the tangent of A and what's the tangent of B? So you're just finding basically two fractions here, because you're using a tangent of A twice and a tangent of B twice. So you're just looking at your triangle and pulling off what is the tangent of A and what is the tangent of B. Once again, do not try to do too many things at one time. Keep it simple here. It does not need extended types of writings here. Bless you. We have the tangent of A minus B. I have one tangent A minus tangent B over 1 minus tangent A times the tangent B. We go to our triangles. What is the tangent of A? What is the tangent of B? Abby Farlow, what's the tangent of A? Look at your triangle. Triangle A, what's the tangent? What's the tangent defined to us as? 3 over negative 4. Okay, what is the tangent of B? Go ahead, Abby. You're on a roll. 5 over 12. Okay, I'm just pulling off my triangles. Now, I have the negative on the bottom. As we talked about before, we can move that negative anywhere we want. We can move it down here at the bottom. We can keep it there. I can throw it out front. So I'm going to throw it out front. I can change any two signs that I want here. So I'm going to make that a positive and just bring my negative out front. So I have a negative 3/4. Positive divided by negative is a negative. Then on the bottom, I'm having the tangent of A again, which is negative 3 over 4. And the tangent of B is still 5 over 12. Now, my one suggestion to you, and I mean, there's different ways of dealing with this now at this point. If I keep the same negative 3 over 4 on top minus 5 over 12, that is fine. What I would suggest you do is multiply these two fractions together to get one fraction. And how we multiply fractions, once again, is we multiply the tops and multiply the bottoms. So go ahead and multiply your two tops, multiply your two bottoms. Come down to one fraction. Multiply your two tops, multiply your two bottoms. I have negative 3 times 5. I have 4 times 12. Don't even need to simplify it. Just multiply it. Sorry, what did you come up with? Negative 3 times 5? And 4 times 12? Okay, so we have negative 15 over 48. Now, there's two ways to approach at this point. There's the easy way, which is typically the way we tend to go, or there's a way of challenging yourself and making yourself a better math student. Okay? If we quantify the numerator and denominator, we can click-clack through our calculator. Okay, we have quantity, parenthesis, negative 3 divided by 4 minus 5 divided by 12, and quantity. Divided by quantity, 1 minus a negative 15 divided by 48, and quantity. We hit our math button. It converts us to a fraction. So I'm going to change that to a fraction. You hit enter, and then you hit enter. And you get your solution. If you want to encourage yourself to become a better math teacher, or not math teacher, math student, look at your denominators, get a common denominator. We got 4, we got 12, we got 48. Multiply your numerator and denominator by that common denominator. We have a complex fraction. Which means we're going to multiply each and every term by 48. So we have negative 3/4 times 48 over 1. The 4 and the 48 cancel to give us 1 and 12. So we have negative 36. multiplying the 48 over 1 times 5 over 4, 5 over 12. We have 1 and we have 4 and then we have 1 there. So we have minus 20 or 4 times 5. On the bottom, we multiply each of our terms. So we have 48 minus a negative 15. The 48s will cancel. So we're left with negative 56 over 73 or 63. Over 63. We could take 7 out of top and bottom. So we have negative 8 over 9. We get our same solution. Bless you. This is a way to enhance your mathematical skills. If you use a calculator and you want to simplify using calculators, that is fine. Do what we do with the calculator. Now, what this is equal to is this is the tangent of A minus B. To find the cotangent of A minus B, all we have to do is flip it over. So we have negative 9 over 8. And once again, I can tag that negative anywhere I want. I had a wrong answer on the solution set. Shame on me. Anything else on the front? I said it was wrong on the solutions there. They got the tag a negative with 15. Any other ones on the front? Yes.
On number 6, for the denominator of whenever we simplified it, should it be 1 minus or 1 plus? Because on the notes, I thought we had 1 plus for tangent A minus B.
I goofed that up. So that should be a plus there. That should be a plus there. Then that would be correct, and I did it. Okay, so this would be a plus here. That would be a plus here. So that would give me a 33. Not bad.
Thank you.
Yeah.
There you go. Sorry about that. Yeah, it should be a plus there. That makes that a plus. That makes that a plus. That makes this a plus there. So that's a minus there. So it'd be 33 over 56. My fault. Yep. I goof up sometimes. Can't be perfect all the time. Any other ones on the front? Yeah.
On number 6, what did you do? What did you put into the calculator? I didn't see that.
This right there. I typed in negative 3 minus negative 3/4 minus 5/12, and that should be a plus. So I'll change that to a plus. A negative 15 divided by 48. I hit math. I hit enter and hit enter. I got my answer. Anything else on the front side? Yeah. On the front. Anything else on the front before we go to the back? Okay, let's go to number 9. We have tangent 2 theta minus tangent of 50, and this is all over 1 plus tangent 2 theta times the tangent of 50 is equal to negative square root of 3. Okay, now, when I'm trying to solve equations, my suggestion to you is, because you're going to have to make a comparison to our formulas, just write in an A and a B above the 2 theta and the 50. But then we ask ourselves, I'm looking at the left-hand or right-hand side of my equations here. I'm trying to go from right to left. So I'm looking for a tangent A minus tangent B over 1 plus tangent A tangent B. Okay? And we're trying to take it back to the left-hand side. Well, when I'm dealing with tangents, I'm either going to be dealing with tangent A plus B or A minus B. Which one do we have here? Tangent A plus B or tangent A minus B? Tangent A minus B. So the tangent of A minus B, okay, is your tangent A minus tangent B over 1 plus tangent A tangent B. Okay, that's what we have there. Well, my A is 2 theta and my B is 50. So we have the tangent of 2 theta minus 50 is equal to negative square root of 3. Now, we never did a tangent one before. We always did sine and cosine, but I'm looking to get rid of tangent. So what are we going to have to do to get rid of tangent? Nolan?
Inverse?
Inverse tangent. So let's take the inverse tangent. Inverse tangent of, don't lose your negative sign, negative square root of 3. So we can click it and make sure in degree mode, inverse tangent, negative square root of 3. We get a degree measure. The degree measure is what, Chloe? Negative 60 degrees. Now, when we did the inverse sine, we came down to a second solution, the inverse sine and the principal value in its supplement. When we did the inverse cosine, we did the principal value and its opposite. Came down to 2 solutions. When we deal with inverse tangent, do we have a second solution? And the answer is no. The answer is no. We don't have to worry about a second solution. The reason why, a couple reasons we can take a look at here. If we did negative 60 degrees, we have square root of 3, we have, this would be 30, and this would be 1, this would be 2. And the square root of 3 would be a negative. So if I took the tangent of negative 60 degrees, I have negative square root of 3 over 1. Okay? If I would take this up into quadrant number 2, if this is 60 degrees, I have a line here and I have a line here. What does this angle have to be up here? This is 60. What's this angle? 60. What do you remember what type of angles we have there? Vertical angles. These are vertical angles, which would get me square root of 3 here, a -1, and a 2 here. If I would take a look at this tangent, I would have square root of 3 over -1. I would still have the negative square root of 3. Well, to go from -60 to this 60, which would be 120 degrees. I can take -60 and add 180 degrees to it, and I come up here. If I take 1, which would be a value of 120. If I would take 120 degrees and add another 180 degrees to it, it would take me back down to here, which is 300, bless you. So I can go from quadrant 1 to quadrant 2, or quadrant 4 to quadrant 2, and then back and forth by just adding 180 degrees. So I don't need a second one. If we took a look at the graphs of sines and cosines, the graph of sine and cosine, we take a look at, it doesn't matter. If we take a look at these cotangent, we use our sine as our guide. We went and we drew asymptotes at these values. And with the cotangent one, we were upper left to lower right. This was 180 degrees. This is 360. If we would take a look at the period for the tangent, okay, once again, let's go back to our definitions of the period. The period was the number of degrees in a cycle. Cycle is a point on the graph to another point on the graph where it starts to repeat itself again. If I go up here, I've done one cycle here. And at this point, I start a second cycle. So if I take a look at the period for tangent and cotangent, for sine and cosine, the period was 360 degrees. For tangent and cotangent, the period is only 180 degrees. So it's 180 degrees divided by b. So when I'm dealing with tangent and cotangent, when I'm dealing with a tangent and solving equations, I don't have to do a second equation because the period here is only 180 degrees. That takes me from here to here, back down to here, back to here. When I dealt with inverse sine, the problem I had with inverse sine, I went from quadrant 1 to quadrant 2, an angle and a supplement. So I kept on going back and forth between these two. That's why I continued to add 360, because I couldn't go back and forth. When I did cosine, I went from quadrant 1 to quadrant 4. So I just had to keep on adding 360 degrees to take me back up to here, and 360 degrees to keep on keeping me right to there. But with a tangent, I could go from here to here, back to here, back to here. What you have to remember is for the tangent, I don't have a second value, and the period's 180 divided by b. So we can add our 50 to both sides. We're just solving an equation now from algebra. 2 theta is equal to -10. And then we divide by 2. So we have theta is equal to -5 degrees plus or minus the period n. Our b value is 2. So the period is 180 divided by 2, or 90 degrees. We only have one general solution. Other ones on the back.
Wouldn't it be 2 if it's plus or minus and it's -2 and 2? Does that make it 2? -5 and 5.
No, because I don't have to worry about plus minus. I don't have to. Tangent is just one equation, one value. When I take my inverse tangent here, I get one value of the principal value, and that's it.
Yeah.
I don't have to worry about a second value like I deal with cosine and sine. Other ones from the back. Once again, key is to write your A above your theta, B above your angle measure. And then how do I take it from the right back into my left? That gives me my two equations then at that point. Other ones. All right, day 2 with this, same types of problems. Once again, keep up with the material. Tomorrow's going to be a review day, and I hate to give quizzes on Mondays, but we're going to have a quiz on Monday because my goal is to be done by identities by the time we get to Thanksgiving. And we have another set of equations that we have to go through next week. So you need to push yourself a little bit here. Now let's take a look at problem number 1 real quick. I'm asking you for the secant of 105 degrees. Once again, we have 30, we have 45, and we have 60. I don't have a secant formula there, but I can rewrite secant as 1 over what? Nolan? 1 over cosine. So I can find the cosine of 105. Well, which one of those two do I need to add or subtract to get 105? I got 30, 45, and 60. 60 and 45. Now, if you want 45 and 60, that's okay. You'll be okay. So here's your A, here's your B. So expand out cosine of A plus B. Don't try to sub stuff into it yet. Just expand out cosine of A plus B. Look at your formula sheet. Just use your A's and B's. Should have cosine A, cosine B, minus sine A, sine B. Okay, that's what you should be able to recopy from your formulas. Okay, we can sub in. Wherever I see an A, I'm putting in a 60. Wherever I see a B, I'm putting in a 45. Now, as you get more and more familiar and comfortable with this, you can probably skip this step. We have our 30/60s and 45 triangles. 1, 1, square root of 2, 1, 2, square root of 3. Looking at your triangles, what is the cosine of 60? What is the cosine of 45? Once again, rationalize that. What is the sine of 60? What is the sine of 45? Cosine of 60 should have one tooth. Cosine of 45, square root of 2 over 2. Once again, rationalize it. You have 1 over square root of 2, so you have square root of 2 over 2. Sine of 60, square root of 3 over 2. And once again, square root of 2 over 2 for the cosine. Multiply your two fractions together. Multiply your two tops, multiply your two bottoms. Multiply your two tops, multiply your two bottoms. And put them all together over top of one denominator then. So you should have square root of 2 minus square root of 6 over a value of 4. But once again, that's the cosine. To get your secant, we have to flip. So the secant of 105 is the reciprocal of that, which is 4 over square root of 2 minus square root of 6. Now, if I give you this problem on the test and you get to this point, you'll get everything except for 1 point. To get that one additional point, you have to rationalize your denominator, which, once again, that takes it to that next level of mathematics. If you get to this point and show me that you have 4 over square root of 2 minus square root of 6, this is worth 6 points, you get 5 to 6 points. Okay? And my suggestion to you is you do that. And if you have time at the end of the test, come back and rationalize. If you don't have time, leave it alone. 1 point's not a big deal. But to rationalize this, we have to multiply by what? Radical fans?
2 plus radical 6.
Very good. Radical 2 plus radical 6. Radical 2 plus radical 6. This is called the conjugate. It's just a difference of perfect squares. So on the bottom, you're going to be left with 2 minus 6. On the bottom, you're left with 4 square root of 2 plus square root of 6. And the 2 minus 6 gives us 4, and you can cancel with the top then. Gives us negative 4, and you have a negative there. Solutions are provided for you. Have a good day.